Welcome to the lesson on solving system of equations using the elimination method, and today we're going to be using elimination that uses addition and subtraction to solve a system of equations. So the standards we'll be looking at, we're going to be creating equations in two or more variables to represent relationships between two quantities, and we're going to be solving a system of equations exactly, focusing on pairs of linear equations with two variables. So two linear equations with x and y variables. And so the lesson before, we solved systems of equations using substitution, and before that we used graphing to find an answer. So today we're going to be using what's called the elimination method, and we're going to be using the elimination method with both addition and with subtraction. So what is elimination? Well, anytime you've heard the word eliminate, it means you're going to be getting rid of something. So math is the same way. When we use elimination, we're talking about a method of solving a system of equations where one of the variables that we're using gets eliminated or gets canceled out when we combine the two equations. And what we're going to be using to combine those two equations is either addition or subtraction. And so elimination means when we combine the two equations, one of the variables disappears, it's eliminated, and we're left with just a single variable, which allows us to solve for that variable. And there are some steps here to solving using elimination. So the first thing is we want to line up the two equations that we're working with so that the x and y variables are lined up with each other. That allows us to see the like terms that are there, and we're looking for either coefficients that are the same or the opposite. Once we've got them lined up, we're going to either add or subtract based on the coefficients, which will eliminate one of the variables, and then we'll solve that equation for the remaining variable. Once we have that variable solved, we substitute that value back into one of the original equations and solve for the other variable. And then, as always, we're going to write our solution as an ordered pair for x and y. All right, so let's take a look at an example. So we're going to be using elimination to solve this system of equations. So equation 1 is negative 3x plus 4y is equal to 12. And equation 2 is 3x minus 6y equals 18. Now the reason that this system of equations is a good candidate to use elimination is because if you look at the x terms here, the first x term is negative 3x, and the second x term is 3x. So what I notice is that the coefficient for x is negative 3, and the coefficient for x in the second equation is positive 3. So since they are the opposite numbers for coefficients, what that will allow me to do is it makes it easy to combine these two equations to cancel out those x variables. And it'll look something like this. So since the coefficients of the x terms, negative 3 and positive 3, are inverses, we can use elimination by adding equation 1 with equation 2. So if I take equation 1 here, negative 3x plus 4y equals 12, I'm going to add it to my second equation, 3x minus 6y equals 18. And when I say we're going to add those equations, we're going to add everything in equation 1 with everything in equation 2 and see what's left over. So the first thing I want to do is write each of those equations so that they're lined up in a column. Right, so negative 3x plus 4y equals 12, and 3x minus 6y equals 18. So now in order for these x values here to cancel out, I'm going to add them together because negative 3x plus 3x makes 0. So when I add negative 3x and positive 3x, I'm left with 0. Now I took just the x terms first. Then what I want to do is take the same process and look at each of the other two sets of terms here. So I've got 4y in equation 1 and negative 6y in equation 2. And when I combine those two together, I'm left with negative 2y. Because if I take 4y and I subtract 6y, I've got negative 2y. And then the last thing is to combine the 12 and the 18 on the other side of the equal sign. So when I combine 12 and 18, I'm left with 30. Okay, so in elimination, what you want to do is you're combining each part of the equation with its counterpart in a second equation. So when we added these two together, we added the x terms together and they canceled out to 0. We added the y terms together and we're left with negative 2y. And then we added this side of the equal sign, the constants, and 12 and 18 gave us 30. And so what's left is, since this is 0, I don't need to write the 0, I can just leave it empty, and I copy this down as negative 2y is equal to 30. So hopefully you're able to see what happens when we combine equation 1 with equation 2. We're combining the x terms together with addition, we add the y terms together, and we add this third column, the constants. Right? And what's left is negative 2y is equal to 30. So now if I want to figure out what y is, I'm going to take negative 2y and I'm going to divide both sides by negative 2. That cancels out the negative 2 on the y side here. And on the other side, if I do negative 2 into 30, or 30 divided by negative 2, I'm left with y is equal to negative 15, because a positive and a negative makes a negative. So by combining these two equations, I was able to eliminate the x values, or the x variables. And when I'm left with just a single y variable, I can solve the equation for y. And in this case, y is going to be equal to negative 15. So the first part of my answer for this system is that y is going to be equal to negative 15. Now I need to take that information and use it to figure out what x is. And so we're going to take y equals negative 15, and we can substitute it into either of the original equations to figure out what x is. So here let's take the first equation. Negative 3x plus 4y equals 12. So I'm going to take the y variable here and I'm going to replace it with negative 15, because we found that y was equal to negative 15 based on our first step by eliminating the x variable. So when I replace y with negative 15, negative 3x plus 4 times negative 15 is 12. Well, 4 times negative 15 is negative 60. So negative 3x minus 60 equals 12. So now I need to solve for x. So since I'm subtracting 60 here, I got to get rid of the 60, so I'm going to add it to both sides. Negative 3x minus 60, add 60 to the left side, add 60 to the right side. So these 60s on the left cancel out, and we're left with negative 3x. And on the right side, we have 12 plus 60, which is 72. So negative 3x equals 72. Now to figure out what x is, I'm going to divide both sides by negative 3. And that leaves me with x is equal to negative 24. 72 divided by negative 3 is negative 24. So what we found was that our y value, when we first eliminated x, was negative 15. And now I see my x value is negative 24. So I'm going to write my solution as an ordered pair. So that means I'm going to list x first. So it's going to be negative 24 and negative 15. So that's the combination of x and y that works in both of those equations that we were given at the beginning. So x is negative 24, y is negative 15. Right, so go ahead and try this one on your own. Take 3x minus 5y equals 1 and 2x plus 5y equals 9 and use elimination in order to solve the system of equations. And the correct answer is B, x is 2 and y is 1. Let's walk through so you understand how we got that solution for this system of equations. So if I take the two equations, 3x minus 5y equals 1 and 2x plus 5y equals 9, what I see is that the y terms here, the coefficients are the opposite. In the first one, it's negative 5y, and in the second one, it's positive 5y. So when I write these out, 3x minus 5y equals 1. And 2x plus 5y equals 9. What I can do to cancel out those two opposite y terms is simply add equation 1 with equation 2. So I'm going to take the first equation and add it to the second one. And what that means is I'm just going to combine the x terms, the y terms, and the constant terms on the opposite side of the equation. All right, so I start with 2x plus 3x. And when I add 2x and 3x, I get 5x. And then I can combine negative 5y and positive 5y, and those cancel each other out, so we're left with 0. And you don't have to show the step of showing the 0, but it's a good way to visualize what's going on here. And then the third column, I'm going to add together 1 and 9, and that gives me 10. So once I combine equation 1 and equation 2 using addition, we're left with 5x is equal to 10. And then to solve for x, I'm just going to divide both sides by 5. So x is equal to 2. So by eliminating the two y values, I figured out that x is equal to 2. So I know that that is my x value in my ordered pair, or in my solution. All right, then once we know x is equal to 2, I can choose either equation 1 or equation 2, replace x with 2, and solve for y. So let's take the second equation, 2x plus 5y equals 9. And we're going to replace x with what we just found x was, which was 2. So I'm going to do 2 times 2 plus 5y is equal to 9. So 2 times 2 is 4, plus 5y equals 9. Then I need to solve for y, so I'm going to take away that 4 from both sides of the equation. So we take away the 4 here on the left, we take away 4 from the right. What we're left with, 4 minus 4 is 0, so all that's left on the left-hand side is 5y. And on the right, 9 minus 4 is 5. We solve for y by dividing both sides by 5. So y is equal to 1. So my ordered pair, my solution to both equations, 3x minus 5y is 1 and 2x plus 5y equals 9, is x is equal to 2, y is equal to 1, so the correct answer is B. All right, let's take a look at a word problem. It says 4 times one number minus 3 times another number is 12. 2 times the first number added to 3 times the second number is 6. Find the numbers. So when you're looking at a problem like this, you want to make sure that you break down all the information that you have into manageable parts. So we know we're dealing with two numbers, right? One number and another number. And then in the second part of the equation, again, 2 times the first number, so number 1, and the second number. So we're dealing with the same numbers in two different situations. In the first one, we're doing 4 times the first number minus 3 times the second, and that gives us 12. In the second, 2 times the first number is added to 3 times the second number, and that gives us 6. So we need to come up with variables for the first number and the second number. So the easiest is just to make x equal to the first number and y being the value of the second number. So we give each of the numbers that we're looking for a different variable. So x is the first number, y is the second number. Then we write equations based on what we know. So 4 times the first number minus 3 times another number is 12. So 4 times one number is 4 times x. 3 times another number is 3 times y. We're subtracting those two, and our answer is 12. So it's 4x minus 3y equals 12. That's our first equation. Our second equation is 2 times the first number, and again, that represents x, so 2 times x added to or plus 3 times the second is 3y, and that's equal to 6. So 2x plus 3y equals 6. So now we have two equations based on the information that they gave us. 4x minus 3y is 12, and 2x plus 3y equals 6. So now I can write those two equations and use elimination to solve the system. So we're going to line them up, again, in x, y columns, and then the constants on the other side of the equation. And what you should notice is that in the first equation, the coefficient of y is negative 3. And in the second equation, the coefficient of y is positive 3. So since those coefficients are inverses, this is a candidate to use addition to eliminate those two y values here, negative 3y and positive 3y. So we're going to add the system of equations together. So that means we're going to add 4x and 2x. We're going to add negative 3y and positive 3y. And we're going to add 12 and 6. So what does that give us? Well, if I add 4x and 2x, that gives me 6x. The negative 3y and positive 3y cancels out and it's 0. And on the other side, 12 plus 6 is 18. So we're left with 6x is equal to 18 because the y variable is eliminated. So now how do I solve for x? Well, 6 times x is 18. I'm going to divide both sides by 6, which leaves me with x is equal to 3. So we found our first number in this system is 3 for x. We use that now in either one of our original equations to figure out what the second number is. So we substitute 3 for x into either equation to find the value of y. So 4x minus 3y is 12. We use the first equation. But now instead of x, we're going to use what we found x to be, which is 3. So 4 times 3 minus 3y equals 12. 4 times 3 is 12, so 12 minus 3y equals 12. And because we're looking for y, we're going to eliminate the 12 that's over here. So since this is a positive 12, we're going to be subtracting 12 from both sides. So 12 minus 3y, I take that 12 away, and on the other side, 12 minus 12. So once we simplify that, the 12s on the left cancel out. We're left with negative 3y, and 12 minus 12 on the right side is 0. And since negative 3y equals 0, if we divide both sides by negative 3, we're left with y is equal to 0. So our solution for our two numbers in both of those systems is for the first number to be 3 and the second number to be 0. All right, go ahead and try this one on your own. Make sure you write the equations correctly, identifying what's going to stand for your first number or what's going to stand for your second number, and then you'll be able to use elimination in order to find the solution to the two numbers. All right, you should have gotten a solution of negative 3, 2. So how did we get that? Well, first we need to set up the two equations that we have. So what do we know? We know that we're dealing with two different numbers. Right? So one number can be x and one number can be y. And in the first situation, we're dealing with 4 times one number. So that's going to be 4 times x. So 4 times one number is added to another number. So we're adding it to our second number, which we're going to call y. So 4x plus y is equal to negative 10. Right, so that's our first situation. 4 times one number added to another number is negative 10. Then our second situation is that 3 times the first number, which we call x. So 3 times x minus the second number, so now we're taking away y, is going to be equal to negative 11. And so we've got this system of equations here, and since the coefficient for the first equation is positive 1y, and in the second equation it's negative 1y, since those are inverses, I can add these two systems together to cancel them out. So we're going to combine our x terms first, 4x plus 3x, and that gives me 7x. When I combine positive 1y and negative 1y, I'm left with 0. Right? So I don't need to write the 0 because they cancel each other out. Right? And then on the other side, we're left with negative 10 and negative 11. So if I combine negative 10 with negative 11, I get negative 21. Okay. Since they're both negatives, negative 10 and negative 11 together makes negative 21. So after I combine these two equations, I'm left with 7x is equal to negative 21. So in order to solve for x, we're going to divide both sides by 7, which leaves me with x is equal to 21, negative 21 divided by 7, and a negative divided by a positive is a negative, so 21 divided by 7 is 3, making this solution x is equal to negative 3. So by eliminating the y value, I'm able to see that x is equal to negative 3. Once I know that, I'm going to pick one of my two equations, solve for y by replacing x with negative 3. So let's just choose the first equation, 4x plus y is equal to negative 10. And now I'm going to replace x with negative 3. So 4 times negative 3 plus y is equal to negative 10. Four times negative 3 is negative 12 plus y is equal to negative 10. So to solve for y, I need to get rid of the negative 12 that's there. And to do that, I'm going to add 12 to both sides. So negative 12 plus 12, negative 10 plus 12, and that's going to leave me with a final value of y is equal to negative 10 plus 12, which is positive 2. So my x value for this system is negative 3. My y value is positive 2. That's the combination that works in each of these situations. 4 times negative 3 is negative 12, plus 2 is negative 10. 3 times negative 3 is negative 9, minus 2, negative 9 minus 2 is negative 11. So we see the combination of negative 3 and positive 2 works in each of the situations that they gave us. Okay, so in our first two examples, we were able to eliminate one of the variables by combining the two equations using addition, because the coefficients of one variable in the first equation was the opposite of the coefficient of the variable in the second equation. Right, but what happens if instead of them being the opposite, such as 3 and negative 3 or 1 and negative 1, what if they're the same value? So if we look at these two equations here, we've got 4x plus 2y equals 28, and 4x minus 3y equals 18. So you should notice that the coefficient for x in both equations is the same, positive 4. So if the coefficient is the same, we can still use elimination, but now instead of doing addition, we're going to eliminate using subtraction. Because if we've got 4x, we want to take away the 4x that's underneath. So we're actually going to take away the entire second equation. Instead of combining them, we're taking the second equation away from the first equation. So since the coefficients of the x terms are the same, we can still use elimination, but this time we're going to use subtraction. We're going to subtract the equations. So the first step is to write them, just as we did with addition, is to write them in columns, lining up the x and y terms. But now instead of adding, we're going to be doing subtraction. Now, one thing to keep in mind when you do subtraction, you got to be careful. When we subtract, what happens to all of the terms from the equation that we're subtracting is they become the opposite. So if we're subtracting 4x minus 3y and 18, okay, when I subtract 4x minus 4x, I have 4x and I take away 4x, I'm left with 0, right, because I'm subtracting it. But what happens when I do 2y minus negative 3y? Well, this negative 3y becomes a positive. So the subtraction in the second equation is actually going to change all of these signs to the opposite of what they are. So 4x minus 4x is 0. Now 2y plus 3y is 5y. And then when I come over here to 28 and 18, I'm doing 28 minus 18, which will leave me with 10. So when you're subtracting, you need to be careful that you're subtracting each term. And what that means is you're actually going to be changing whatever sign is there to the opposite sign in order to do the subtraction. All right, so when we combine these two equations using subtraction, we're left with positive 5y and 10. So 5y is equal to 10. Again, because when we subtract, all of the signs that we have become the opposite. So the 4x in the second equation becomes negative, the negative 3y becomes positive, and the 18 becomes negative. So we're doing 4x minus 4x, 2y plus 3y, and 28 minus 18. So we're left with 5y is equal to 10. And so to solve for y, we divide both sides by 5 and find that y is equal to 10 divided by 5, or 2. So by subtracting these two equations, we find that y is equal to 2. Now our process is the same as just in our first two examples. We're going to take this value now, y is equal to 2. We're going to replace y with 2 in one of our two equations and solve for x. So in the second equation, we take 4x minus 3y equals 18. We're going to replace y with 2. So 4x minus 3 times 2 is equal to 18. 3 times 2 is 6, so we simplify it to 4x minus 6 equals 18. Now I need to get rid of everything here in order to solve for x. So since I'm subtracting 6 here, I need to add 6 to both sides. So 4x minus 6 plus 6 is equal to 18 plus 6. So these 6's on the left cancel out, so we're left with 4x is equal to 18 plus 6, or 24. And now to solve for x, we divide both sides by 4, and we find that x is equal to 6. So our solution is that x is equal to 6 and y is equal to 2. And we got that by subtracting the two equations. All right, so now it's time for you to try one on your own. We've got 9x minus 2y equals 30, and x minus 2y is equal to 14. Again, since we've got two coefficients that are the same, negative 2y, you're going to want to use subtraction to solve this system by using elimination. And you should have gotten a correct answer of D. X is 2 and y is negative 6. So let's take a look at how we solve that. So we're taking each equation, and again, because we have the same term in both equations, negative 2y, so 9x minus 2y equals 30, and x minus 2y equals 14. Since we've got negative 2y in both equations, we can subtract the two equations from each other in order to cancel those out. So I line up the two equations, and I'm going to subtract this second one from the first one. And again, when I subtract, what that's going to end up doing is going to change all the signs in the second equation to the opposite. So I'm going to do 9x minus x, negative 2y plus 2y, and 30 minus 14. So when I take 9x and I take x away, I'm left with 8x. The y's cancel each other out, which is what I wanted, and 30 minus 14 is 16. Then to solve for x, we're going to divide both sides by 8. And when I divide 16 by 8, I find that x is equal to 2. So x is 2. So that's my first part of my solution. X is 2. Then I can replace x with in either equation that I want. So let's take x, the second one, x minus 2y is equal to 14. And instead of x, I'm going to use my value that I just found, so 2. So 2 minus 2y is equal to 14. So now we just solve this equation for y. So we're going to take 2 away from both sides, which on the left will leave me with negative 2y. And on the right, 14 minus 2 is 12. Then to solve for y, I divide by the coefficient of y, which is negative 2, so divide both sides by negative 2. And 12 divided by negative 2 gets me my solution for y, which 12 divided by 2 would be 6, but since we've got a negative in one of the numbers, 12 divided by negative 2 makes y equal to negative 6. So my combination is that x is 2 and y is equal to negative 6, which is the answer is D. All right, so a word problem. A hardware store earned $956.50 from renting ladders and power tools last week. The store charged 36 days for ladders and 85 days for power tools. This week, the store charged 36 days for ladders, 70 days for power tools, and earned $829. So how much does the store charge per day for ladders and for power tools? So if we look at what the question is asking us to solve, it's asking us to solve for this. How much does the store charge per day for ladders and power tools? All right, so I've got two different variables here. I've got x and y. All right, and we're looking for the amount that they're charging per day for each of those things. So if I call ladders x and power tools y, just know that my answer when I get that is actually going to be an amount of money that they're charging each day for those power tools. So if I call ladders x, I'm actually referring to the amount of money that it costs per day to rent a ladder. And for power tools, I'm looking, if that's y, then y is going to be the amount of money that I'm paying per day for power tools. All right, so we know the number of days the ladders and power tools were rented and how much the total was for each of those. So let x equal the cost per day for ladders and y the cost per day for power tools. So we can kind of make a two-column organizer here. So we've got ladders, power tools, and the total amount of earnings. So in the first one, 36 days times the amount per day for ladders, so 36 times x, plus 85 days times y, the amount per day for power tools. So when I do 36 times X plus 85 times Y gets me the total amount of money from ladders and power tools, which for that first week was $956.50. The next week, they rented the same number of days of ladders, 36, but 70 days of power tools. So 36X plus 70Y is equal to $829. Right, so if you look at these two equations, you notice that for ladders, since they rented the same amount per week, they have this, or the same number of ladders each week, they have the same coefficient, 36. So when I set up this system of equations, I'm going to use subtraction in order to cancel out the ladders or the x variable in each equation. All right, so we subtract the equations to eliminate one of the variables and then solve for the second one. So by subtracting, remember again, when we subtract, we're actually changing the sign of each term. So 36x minus 36x cancels out. On the second one, we're doing 85y minus 70y, and in the third column, $956.50 minus $829. And let's go ahead and add in that 0 at the end here. All right, so when I subtract all of these terms, the 36x's cancel out. 85y minus 70y is 15. And $956.50 minus $829 is $127.5, or $127.50. So now to solve for y, we're just going to divide both sides by 15. And when we do that, we find that y is equal to 8.5. And remember what y stood for. Y was the amount per day that it costs to rent a power tool. So this 8.5, just to keep in mind, is going to be, since we're talking about money, it's like saying $8.50. And so it costs $8.50 per day to rent the power tools. Now that we know how much it costs to rent the power tools, we can use that to figure out how much it costs per day to rent the ladders. So we substitute 8.5 into y for either equation. So if we take the first equation, 36x plus 85y equals $956.50. Well, we replace y now with 8.5, or $8.50. So 36x plus 85 times 8.5 is equal to $956.50. Multiplying 85 and 8.5 gives me $722.50. So 36x plus $722.50 equals $956.50. So we're going to subtract $722.50. So subtract the 722.5 from both sides. So we take it away on the left, and we're going to take it away on the right. 722.50. And that leaves us with 36x is equal to 234. Divide both sides by 36. Which leaves me with x is equal to 6.5. And again, we're talking about money, so the 6.5 means $6.50. So my combination for x and y, given both systems of equations, is that x is 6.5, y is 8.5, which means that the store charges $6.50 per day for ladders and $8.50 per day for power tools. And we can check by substituting both of those amounts of money into the other equation, the second equation, to make sure it works. So if x is 6.5 and y is 8.5, then 36 times 6.5 and 70 times 8.5 should give us a total of $829, and it does. All right, so go ahead and try the fundraising problem on your own. For a school fundraiser, Marcus and Anissa participated in a walkathon. In the morning, Marcus walked 11 miles and Anissa walked 13. Together, they raised $523.50. After lunch, Marcus walked 14 miles and Anissa walked 13. In the afternoon, they raised $586.50. So how much did each of them raise per mile for the walkathon? So you're going to want to identify both variables that you're looking for and then solve the system based on the two situations that they give you. All right, so the correct answer is that Marcus is raising $21 per mile and Anissa is raising $22.50 per mile. So to get that answer, what you should have done was first identify the variables. So you're going to have to identify what x is and what y is. So x would be the amount of money that Marcus is raising per mile. So the amount of money for Marcus. That would make y equal to the amount of money that Anissa is raising per mile. And then once I know what x and y are, I can start setting up equations. So I know that in the morning, Marcus walked 11 miles and Anissa walked 13. And then altogether in the morning, they raised $523.50. So as an equation, I would say that Marcus walked 11 miles, so that's 11 times however much he raised per mile. So that's the amount of money that Marcus raised, 11 times the amount per mile. Then I add in Anissa, which is 13 miles times y, the amount that she raised per mile. And I know that in the morning then that was equal to $523.50. Then in the afternoon, Marcus walked 14 miles and Anissa walked 13. And in the afternoon, they raised a total of $586.50. So as an equation for the afternoon, we see that Marcus now walked 14 miles and Anissa walked 13. So now if I combine them, I get a new total in the afternoon of $586.50. And looking at these two equations here, I notice that Anissa walked the same amount in the morning and afternoon, 13y, which tells me that this would be a good way to use subtraction in order to eliminate those two variables. So when I do that, when I subtract everything here, what is that going to do for me? All right, so I start with my two equations, 11x plus 13y equals $523.50. 14x plus 13y equals $586.15. Again, I'm going to use subtraction to eliminate these y values here. And so when I subtract, again, that changes all of my signs to the opposite. So I'm subtracting each of those terms here. All right, so when I do that, 11x minus 14x should give me negative 3x. The 13y's cancel out because 13y minus 13y is 0. And then I subtract 523.50 minus 586.50. So that's going to be negative 63. Okay. So my equation is that negative 3x is equal to negative 63. So then to solve for x, we're going to divide both sides by negative 3. And again, a negative divided by a negative is going to give me a positive, so 63 divided by 3 means x is equal to 21. And if we go back, remember, x stood for the amount of money that Marcus was making per mile, or raising per mile. So that means Marcus was raising $21 for each mile that he walked in the walkathon. So x, Marcus was making $21 per mile. So now if I know how much Marcus was raising, I can solve and figure out how much ANISA was raising. So I choose one of the equations. Choose the first one, 11x plus 13y equals $523.50. And now I know x is equal to 21. So I do 11 times 21 plus 13y equals $523.50. When I multiply 11 by 21, I get $231. Plus 13y equals $523.50. We can subtract 231 from both sides. Be careful when you subtract the decimal over here. Make sure you line up the decimal point. Don't slide it all the way to the right. So we're left with 13y is equal to $292.50. We divide both sides here by 13. And that gives me a value of y is equal to 22.50. So that means ANISA was raising $22.50 and Marcus was raising $21 per mile, giving me a correct solution of B. Marcus raised $21, ANISA raised $22.50. So that's how we use elimination using addition and subtraction in order to cancel out either our x or y variables in a system of equations. The keys to keep in mind here that if you've got a system of equations where the coefficients of one of the variables are opposites, such as 3 and -3 or 5 and -5, combine the two equations using addition. And that'll cancel out those coefficients in those variables to where you can solve the resulting equation for the first variable. Once you know that variable, you substitute the value into either the first or second equation to solve the second variable. If the coefficients of a variable in the two systems of equations are the same value, the same number, like 3 and 3, 5 and 5, 7 and 7, you're going to use subtraction. And the key to remembering when you're subtracting, make sure that you subtract each term. So you're going to change each term to the opposite sign. So all the additions become subtractions and all the subtractions become addition. And then you follow the same steps as you did for adding the two equations together. So hopefully that clears things up and you're able to understand how we use elimination using addition and subtraction in order to solve a system of equations.